Alright, so in this problem we are given an integer array nums and we need to find the pivot index. So a pivot index is defined as an index where the sum of all the numbers strictly to the left of it is equal to the sum of all the numbers strictly to the right. And if there is no such index that exists, we should return -1. So for example, if the input is this, the output should be 3 over here. Because if you see, the sum on the left of index 3 equals the sum on the right, that is 11, right? And if the input is, for example, this 1, 2, 3, then the output should be -1. Because if you see, there is no index that balances the two sides. So that's the entire problem, right? That's the entire problem statement. Now let's see how to solve it. So now to solve this problem, we will use a very efficient method with just one array pass. First of all, we will compute the total sum of the entire array. Then we will loop over every element of the input array and keep a track of a running left sum which starts at 0, right? So as we loop through each index, we remove the current number from the total sum that we have calculated already, and this will then give us the right sum. Because at every index, what we are essentially doing is we are just removing that number from the total sum, and so now as we reach any index I, we would have already removed all the elements to the left of I from the total sum, right? Leaving us with just the sum of all the elements to the right of I, and hence it will essentially give us the right sum. And now at each step, we will simply check if the left sum that we are maintaining as a running sum is equal to the right sum or not. If yes, we have found the pivot index and we return it immediately. If not, we add the current number to the left sum and continue. So this way we can scan the entire array only once in order of n time and using constant space. And also remember, while we are comparing the left sum with the right sum, we have to ensure that the current index is not included in either of the side. And that's why we will compare the left sum with the right sum only after removing the current element from the total sum and before adding it to the running left sum. So let's actually understand it with this example. So over here we start with the total sum equal to 28, right? And the left sum is equal to 0. Now at index 0, the number is 1. So we subtract it from the total sum, leaving the right sum equal to 27. Now we compare the left sum, which is 0, with the right sum, which is 27, and we find that they are not equal. So we just add 1 to the left sum, making left sum equal to 1, right? Now at index 1, the number is 7. So we subtract it from the total sum, making the right sum equal to 20, right? Then we compare the left sum, which is 1, with the right sum, which is 20, and again they are not equal. So then we add 7 to the left sum, making left sum equal to 8. Now at index 2, the number is 3. So we subtract it from the total sum. Right sum becomes 17 now. Now we compare the left sum, which is 8, with the right sum, which is 17, and they are still not equal. So then we add 3 to the left sum, making the left sum equal to 11, right? Now at index 3, the number is 6. So we subtract it from the total sum first, making the right sum equal to 11. And now if you see, left sum, which was already equal to 11, becomes equal to the right sum. And that means we have found our pivot index at position 3. And so we just return 3 as the final answer. So that's the entire solution. I hope this is very clear now. Now maybe let's see the code for this. So first of all, we define our function pivot index, which takes the array nums as the input. Now we calculate the total sum of all the elements in nums and store it in a total sum variable. Now we initialize left sum equal to 0 because before the first index there is nothing on the left. Then we start a loop with enumerate to get both index and the value at that index. And inside this loop, we first subtract the current number from the total sum, and after this subtraction, the total sum represents the right sum. Now we check if the left sum is equal to the right sum or not. If yes, we immediately return the current index because we have found our pivot, right? Else, if they are not equal, we simply add the current number to the left sum, preparing it for the next iteration. Finally, if the loop ends without returning any pivot, we simply return -1. So that's the entire code. Now maybe let's talk about the efficiency. So the time complexity over here will be order of n, since we are just traversing the entire input array once, right? And since we are not using any extra space over here apart from a couple of variables, the space complexity will be constant. It will be order of 1, right? So that's the entire solution for this particular problem. And now I will see you in the next one. Happy coding.